gases. So what's the basic equation that we use for ideal gases?
This is electric potential. This is electric potential.
Yeah, PV equals nRT.
So electric potential energy is
So P stands for what? Pressure. V stands for volume. N stands for moles. Moles of what? Moles of gas, right? So if it was a solid or liquid, we're going to ignore that when we're working with P equals nRT because this is for ideal gases, not for liquids or solids. Where's R? Yeah, it's a gas constant. So in this equation, what's the value that we use for R? Yeah, R is going to be 0.08206. And what are the units on this version of R?
So this one gets rid of 62. This one gets rid of all of them.
I think I heard it from a couple of people. It's going to be ATM on the top and what else? ATM, liters per mole, Kelvin. Yeah, this should be on your equation sheet. You'll probably be given the other form of R too, and you'll need to know which one you need to use. So if you're using the ideal gas equation, that's the R that you want to use. So let's look at the first question. We want to find the temperature of 3 moles of gas in a 0.7 liter container that's under this amount of pressure, 5 atmospheres. How do we solve that? Right. We can rearrange this equation in order to solve for temperature. So if we wanted to rearrange the equation and solve for T, we're just going to divide this side by NR. So that would be PV over NR. And then we can just plug in all our information and get an answer. It's just a plug and chug problem. There's nothing too complicated about this one. So if someone wants to do that for us quickly.
Pretending we have like a force
What was that?
we really want to talk about it.
14.22. What are the units on that? Kelvin, right? Because it's a temperature.
And I'm just going to, I'll see this if you want.
Anybody disagree with that, or we all get the same number?
If it is a negative,
All right. So then, if we take this same system and we raise the temperature by 75 Kelvin, the pressure is going to change, right? Because the volume, we're going to assume, since in the problem, and this might be something we have to do on the test, we're going to assume, based on the wording of the problem, that our volume doesn't change. So our volume is still going to be 0.7 liters. In fact, the only thing that we are told that is changing is temperature. But whose law tells us that if we raise temperature, other stuff has to change too? So remember, we have Boyle, Charles, Avogadro, Gay-Lussac. Whose law says that stuff changes when you change temperature? Charles, right? Charles says that if temperature goes up and volume is constant, then what also goes up? Pressure. And if pressure is constant and temperature goes up, what has to go up? Volume goes up, right? So that's Charles' law. So we know if we are raising the temperature and keeping the volume constant, that the pressure is going to go up or down. Up. Is it going to be greater or less than 5 atmospheres? It's going to be greater because it's going up. So how would we solve for the new pressure? Yeah, that's the easiest thing probably to do, is say, oh, we figured out that in this first problem that the temperature is 14.22 Kelvin, and if we are just raising the temperature by 75 Kelvin, we can add these two numbers together, and then all the other numbers are going to be the same except for pressure, because that's what we're solving for now, which is given in the problem for the pressure. So we can rearrange our equation once again in order to get P equal to nRT over V. And T is going to be what now? Right. T is not 75, because we are raising the temperature by 75 Kelvin. So we're going to add these two numbers, and that is going to give us 89.22 Kelvin as our new temperature. Volume is still what? 0.7 liters, because that has not changed. R is still what? R is a constant. R is never going to change. And what is N? N is 3, because we're not adding or removing gas. So if we were to figure out what the new pressure is, it's going to be what? What is that? 31.37 atmospheres. So does that make sense conceptually? If we raise the temperature, the pressure should go up. Did our pressure go up? It did. That makes sense.
Electric potential
Yeah.
energy.